Now let's take a look at how we're adding message queues into our solution. The first part of the process happens when the appointment is scheduled, and you've already seen our Add New Appointment method inside the Schedule aggregate route. And you saw how the domain uses domain events and domain services to notify the user interface if there's a conflict in the schedule. In the previous module, we showed you Mediator, which we're using to publish these domain events. And we also talked about integration events, which are structured to be shared between different applications. So what we're going to do in our system is add RabbitMQ into the mix at the same point where Mediator is publishing the domain events. But we'll ask RabbitMQ to publish our integration events. These events will be formatted as JSON data before they're inserted into the queue. So let's see what this looks like in the application. We'll be looking at the code that makes all of this work a little further on in this module. We'll go ahead and create a new appointment. Let's bring Samson in to see Dr. Jones again. So there's the appointment. Nothing has changed from the perspective of the user. RabbitMQ includes a user interface to inspect the queues. And in the Front Desk app, the menu has a link so that you can open up this admin page and see what's going on with the queues that are associated with this application. We'll head to the queues page and then drill into the Vet Clinic public queue, which is a queue that we set up to handle communication between the Front Desk app and the Vet Clinic public app. And you can see that the one and only message that RabbitMQ is tracking is in that queue. So we'll drill into that queue and then scroll down to see the details of the message itself. And the most interesting part, the payload, which is the JSON expression of the event data. You can see the GUID value of the appointment ID. The client name is Julie Lerman, an email address, which is not really my email address. The patient name is Samson, and other relevant details that came from the integration event. So the Front Desk app knew to publish the message to this queue, and our Vet Clinic public app knows to read from this very specific queue in order to perform the task of emailing the client. Now that the message is waiting in the message queue, it's time to read the message and act on it. And acting on it is the next step in our workflow, sending an email to the client to let them know about the appointment they've just scheduled. We can't do this easily from our scheduler application because we need for the user to be able to click on a link that specifies that they want to confirm their appointment. So it needs to be publicly accessible.
So we've decided to put this on the veterinary clinic's public website. And so that will be responsible both for sending the emails and for hosting the link that the customer will click.
The public site uses a hosted service to periodically check for new things in its queue. Once it finds a message on the queue, it will retrieve the information from that message to create a confirmation email using code like what you see here.
One of the most important pieces of this email is a link back to the public website, not really localhost, which includes the GUID that represents the appointment ID. The website then sends the email. That's what the user will end up clicking on in their email and trigger a confirmation using the website.
All right, so now we're looking at the Vet Clinic public website, which is a super simple demo solution that we put together. And one of the things it does when it starts is start checking for messages, which you can see here.
Right, but we don't have it running quite yet because it would have already pulled the message out of the queue. First, we'll show you the code that's making this all work, and in a bit, we'll step through while debugging.
The public website has a hosted service called Front Desk RabbitMQ Service, which periodically checks the message queue to see if anything new has arrived. As soon as it finds one of those messages off of the message queue, it's going to send an email. And we're going to use a tool called Papercut, which will emulate a local email server for the purpose of testing. Rather than installing this on our dev machines, we're running a Docker container to host Papercut. You can view emails Papercut has received by clicking the Sent Emails link from the Front Desk Apps menu. Currently, there aren't any emails in Papercut, but as soon as we start the web application, it's going to check our message queue and then send an email that we should see appear in Papercut.
There's the message, the same message that we sent out for Samson's appointment. There's a hyperlink that leads us back to being able to confirm. Let's see first, high level, what happens when we click on that confirm button. And then we'll come back and click it and watch it in action. So now the user has the email and their beautiful confirm link in the email. When they click that, it opens up the website, browsing directly to the GUID that was their appointment. And in response, the website calls its own method called confirm, which takes the relevant appointment ID and pushes it into another one of the queues. You've seen the message queue that was used for relaying a message from front desk to the public website, and that was named FDVCP Vet Clinic Public In. Try to say that 5 times fast. But you can have as many queues defined in your system as you need. And one of the other queues that we've defined is for relaying messages from the public website. In other words, when the client has clicked on the button to confirm their appointment, back to the front desk app. Now that the email's been sent, let's see what happens when the client clicks on the confirm link in that email.
When we click on that, we've now confirmed the appointment. Once the user clicks on the confirm link, it drops the message with the confirmation back into the scheduler queue, and you can see that message right here.
Yeah, this middle queue shows that there's one message. Let's look at it. We'll scroll down to the Get Message button, and the message is retrieved and displayed. We've seen this before, where the payload is the JSON data we're looking for, and this one contains the appointment ID that's just been confirmed. Now you can see that the 2 different applications are communicating back and forth with each other using their 2 separate message queues. We've named the queues so that it's clear which applications are using them to communicate and in which direction. The initial acronym specifies which 2 applications are involved. FDVCP means Front Desk and Vet Clinic Public. The latter part of the queue's name says which app is listening to it. The last step now is for this confirmation information that's sitting in the queue to get back to the scheduling app.
Now in our scheduler application, we have implemented a hosted service just like you saw in the public website. This one is called the Vet Clinic Public RabbitMQ service, and it listens to the appropriate queue to see if there are incoming messages that it needs to deal with. When it finds one, it responds to the appointment confirm link clicked integration event, yes, it's a long name, with the email confirmation handler. The handler looks up the appointment from the appointment ID that was contained inside of the message, and from there it calls appointment.confirm. Appointment, as you recall, is our entity, and its confirm method also then triggers some domain events, which for instance our user interface listens to, and when it sees that that event has been fired, it triggers a change in the UI, enhancing the appointment with a green bar across the top to show that the appointment has been confirmed. Okay, so all that's going to happen at this point is that when the message comes through, it's going to make the Samson appointment right here have a green border and pop up a dialog to let us know that a change has occurred.
Very slick. This is actually really easy to implement because we already had the website listening for events. Remember how it was able to display new appointments and display conflicts. We implemented another design rule based on a particular property of the appointment, which is confirmed. All we did was set up another event handler.
We wrote the original sample for the first version of this course in 2013. At the time, things like SignalR and WebSockets, as well as emails with confirmation links, were relatively rare, although we certainly didn't invent these kinds of app interactions.
Right, but now every time I make an appointment for my dentist or hair, and even for Samson in real life to go to the vet, I'm getting texts or emails with exactly these kinds of confirmation links.
I know. I guess maybe a lot of businesses watched our course.